On the 30th of October 2014, HP announced a new 3D printing technology that will change the world. HP Multi-Jet Fusion. Well, here we are in 2016 and an awful lot's happened in the 18 months since HP announced. So let's get up to date.
We have introduced the new HP Jet Series 3D printers. Printers that really will spark a new industrial revolution, printing parts faster at half the cost of other 3D printing technologies. Not only a printer, but an end-to-end solution, a new open platform of materials and solution.
It's a game changer in terms of productivity and speed, which will enable our customers to go to places where today it's unthinkable of.
Okay, so here it is, the mighty Voxel, a pixel in 3D. HP's technology allows us to build 3D parts, voxel by voxel. Multi-jet fusion technology ejects tiny agent particles, 20 microns, onto the powder bed. Multi-jet fusion technology can now combine 2 or more agents. Why might that be important? Well, because the fusing and detailing agents combine and then change the thermal behavior of the material, which means a much higher quality part is produced. That then happens across every voxel.
We also have a thermal camera in there, which is actually measuring the real temperature that we have in this bed. We actually have 900 points, so it's 30 by 30 matrix, and we can know exactly which is the temperature in each of those parts. So what we do is we model the parts that we are going to print. We know exactly how much energy we need to put in there, and afterwards we measure real time and we adapt.
Other point-to-point 3D printing technologies require chemically reactive polymeric materials, and this is to compensate for the limited energy exposure time. As a result, the materials have a tendency to react, so they become less reusable. And importantly, the materials degrade over time as a result. Now, with HP's multi-jet fusion technology, it does not require reactive polymers. So the materials can be used and reused time and time again, achieving amazing powder reusability rates that set a new standard for the industry. It brings the running costs substantially down.
With this material, you can have a build with up to 80% of material that is being reused from previous builds and 20% of fresh material.
The unit will automatically load the fresh material with the reused material with the required proportion. And that is being done automatically, saving time and being even more productive.
Now, HP has also been designing a full end-to-end solution to streamline workflows and minimize material waste.
This end-to-end solution that we provide is easily transferable to an industrial plant, to a production line. So really now there's no excuse. 3D printing can go into industries.
We have a printer that is really fast. So we really need to have a fast process for doing the cooling. And that is also being done in the processing station.
This is in fact one of the parts in the processing unit. And this part, along with 50% of the other plastic parts, have actually been manufactured with HP Multi-Jet Fusion. The printer is printing itself because it's the most economical way to do it. Let's now look at software.
Here we have our build manager that will deliver one of the best attributes in the market in the sense of opening a file, analyzing it, auto-packing it, and making it ready to print.
HP's strategy is to take an open source, open platform approach. HP is collaborating as a major player now in the 3MF consortium, and they're developing a new file format that will overcome the limitations to widespread adoption.
And with our collaboration with design software vendors, we will really need to transform also the engineering community, the designer community, to take full advantage of these new tools.
I believe that open is the way to go in 3D printing. We've seen both open and closed approaches used in 3D printing. An open approach accelerates innovation. In 3D printing, it's a critical pathway to success.
Materials is one of the main areas to drive adoption in 3D printing. Materials that enable new applications.
This innovation is key to enable another level of 3D printing. color, chemical properties at the voxel level. This will help drive the dream that 3D printing industry has had for a long time to become a manufacturing digital industry.
Embedded intelligence with multi-jet fusion. What this allows us to do is embed sensing and communication into 3D printed parts. As we continue to add weight, you'll see it will tick up, registering a new weight, and continuingly to march towards an unsafe zone.
Scan this part and instantly I have all the information, how to assemble this, when was it built, how do I reorder it.
So the materials that I'm talking about are photoluminescent functional agents that allow us to print information onto an object without actually showing the information.
So HP is taking really its first step on a journey to reinvent how prototypes and final parts are produced through its unique 3D printing technology, sweeping away all the barriers for wide-scale adoption. This really is the next industrial revolution.